All right. Good evening, everybody, and welcome. So we're here tonight for the meetup of why change management is key to the Salesforce architecture. So first, short introduction about me. I'm Kid Jansen, Chief Sales Architect at Capgemini, and also a Deputy Salesforce CTO for the Netherlands. Been working with in CRM for 12 years now. Salesforce for 7, and last 4.5 of those as an architect. And apart from quite a few Salesforce certs, I also have certifications in TOGAF, in SAFe, Copado, and various Scrum certs. So what does the agenda look like for today? First, I'll cover the problem statements. So basically the why we are here and why I think that change management is a key factor in Salesforce architecture. Then some context, some background to make the rest of the story more understandable. So I'll discuss the 3 axes, how I see it, of architecture, which in my opinion are methodology domains, architectural domains, and layers. Then I'll discuss the traditional top-down approach of Salesforce architecture in general, but also how that fits on Salesforce, or actually doesn't fit. Then more in depth about the problems with using the top-down approach to architecture with Salesforce, why the bottom-up approach isn't architecture, and finally, how you can leverage change management for a better approach to sales architecture. So first off, the problem statements. The reason why I think that traditional architecture approach with the top-down approach doesn't fit well with Salesforce is because of the cloud, the multi-tenant, and the as-a-service characteristics of Salesforce. Salesforce is a platform as a service, a PaaS, and because of that, you get a lot of functionality out of the box, but that functionality is mostly fixed. Like you have all the different clouds, for instance, that are available on the core platform, like Sales, Service, Experience Cloud, and you can configure a lot of functionality yourself. For instance, the custom objects, the automation in Apex, in flows, etc. But a lot of the underlying functionality to support that, or actually pretty much all of it, is fixed. You cannot, for instance, modify the governor limits yourself, or you cannot improve the performance by, let's say, upgrading servers to one with a better CPU or more memory or anything like that. So there's a lot of constraints that are provided by the platform because it's a PaaS platform and because it's cloud and multi-tenant. And on top of that, there is the SaaS aspect, so software as a service, meaning you get, for instance, Service Clouds or Sales Clouds or other clouds that also provide functionality out of the box. So it's not just a platform, it's also a lot of functionality. And you want to leverage that. You don't want to conflict with the functionality on the platform, but instead you want to make use of that. And that means that sometimes you will have to change your process, your way of working a little bit to leverage those capabilities, even if they don't fit perfectly with your original process, instead of building something next to it that is very similar, but completely custom, and then conflict with existing functionality or limit your options to expand, etc. This means that the traditional architecture, looking from business to a functional solution to a technical implementation, and moving top down across the layers, so from the high-level enterprise architecture down to systems, down to key capabilities, down to features, doesn't work well with Salesforce because you push Salesforce in a direction towards customization that it doesn't really support properly. And the result of that is that the implementation quality will drop significantly. The other way around, bottom up doesn't work either. It's quite a common approach, though. You see it especially with smaller implementations. And bottom up architecture basically isn't architecture. It's that you have a backlog that's mostly comprised of stories looking at feature requests. So really the lowest level of functionality, the most specific parts, and that you then start delivering also story by story, delivering features. Problem is that if you take that approach, you don't have a holistic view of the solution as a whole. So you tend to start optimizing steps or really small piece of functionality rather than the end-to-end process and the end-to-end solution, which typically results in suboptimal processes, but also conflicts in implementation, where one solution is sort of hurting the performance or the user experience or customer experience of a different functionality. So what we're here for tonight is to discuss what approach could work better for Salesforce. And to start off with that, I would like to first provide some context. And we'll start with the system of systems thinking. So what's the idea? System of systems thinking means that you split up something really complex, something really big, into different parts. So I took a couple of examples that are not IT related. For instance, the largest building in the world is approaching over a 1 kilometer or 1 square kilometer floor area. Largest passenger planes are composed of 46 million parts, cars 30K parts on average, microprocessors that have 100 billion transistors or more. So these are examples of very complex systems or structures that could in no way be engineered on one layer, on one level. It's much too complex for that. There's way too many parts. If you would design the architecture for that, even if the scale would be appropriate for an A4 size paper, you wouldn't even have enough size on the side of a building to define that level of detail for the full system, for the full structure you're designing. So instead, you have to split it up. And these examples have nothing to do with software or with IT systems, but the principles are not different. We've been constructing buildings for thousands of years. We've been making machines for thousands of years. And those very same principles still apply to IT as they do to many other things that require architecture today. Working with parallels like these can also make the whole architecture process more easy, because you can make very abstract concepts that are not very tangible for the business or not really understandable, much more understandable with these parallels, because they relate to something they can better understand, because it's physical, they can see it, they can understand how it works. So the same thing can be applied to IT. You can, instead of thinking of, for instance, Salesforce implementation as a whole, you can split it up into various parts. For instance, you can look at it by cloud. So we have Sales Cloud, Service Cloud, Community Cloud, Experience Cloud nowadays. And within those, we have key capabilities. For instance, in Service Cloud, you can have omnichannel, and below that, you have features. So you can take a granular approach where you go into more detail with every layer you go down. And one key thing to keep in mind is that providing structures, looking at these things as a system of systems, as something that has subsystems or assemblies or parts, doesn't mean that you're creating silos. You still take an holistic view, an holistic approach on each layer, and the end-to-end solution, end-to-end process, it's managed on the higher layer, basically. So it's not like you isolate features or isolate functionalities. You still look at the whole thing, but just you separate the design process and sort of take a black box approach in some areas. And when you dive down one layer deeper, there you define the detail. So how can we do this? I see it as that there can be three axes to architecture. Vertically, we have the layers, and there are multiple frameworks that support that. For instance, in SAFe, we have the enterprise architecture layer, the large solution layer. It's a bit small, but I'll go into much more detail later in separate slides. But here, for instance, you have the enterprise architecture layer. Here you have the wait, let me enable the pointer. My bad. So here you have the enterprise architecture layer, here the large solution layer, and then this is the system architecture, which actually has two layers. One is the one for the system as a whole, which has one agile release train, and then within that you have the separate teams working on separate backlogs for capabilities or parts of the system as a whole. Another example is the C4 model, which is also mentioned on the well-architected pages on architects.salesforce.com. This is one quite standard model that defines also 4 layers of architecture, where the top layer is the context, then you have sort of container, which map roughly to key capabilities, then the components, and then finally it's the code or the steps in the process, depending on whichever way you look at it. Then at the bottom we have the TOGAF ADM. So that's the second axis, and these are architecture process domains. So it's not really a dimension of architecture itself, it's more the process of getting to architecture. But it also includes other dimensions in that process, for instance, time. When you have a current situation, like the customer has a certain landscape now, for instance, if it's a greenfield project, which doesn't include Salesforce, and they want to go to Salesforce, but maybe that path as a whole will take 2 or 3 years. So you might not be able to, you cannot switch from the old situation to the new situation in a single day. It doesn't happen overnight. So there might be certain milestones in between with temporary solutions to sort of bridge the gap as a transition architecture before you get to the end state. So that's covered in the TOGAF ADM to some extent, where you have separate steps for business architecture, information system and data architecture, and technology architecture, and then follow up by filling that in with solutions to those requirements. And that solves multiple areas, which are also mentioned on the left side. So it includes the time aspect. It includes the part where you go from requirements. So sort of black box description. You don't care how it works. You are only defining the what to the solution. So where you do define how it works. And also the functional versus the non-functional aspect. And then finally, the third axis is the architectural domains. And those are sort of different perspectives that you can take towards architecture. And I'll cover that one in a couple slides. So a bit more context. So first, the TOGAF ADM. So as I mentioned, in TOGAF, we take a look at business architecture, then information system architecture, which is comprised of application architecture and data architecture, and then finally technology architecture. This is a bit of an old-fashioned approach, maybe. It's more tailored towards fully custom developments, where you also define the full infrastructure. So not just the application, but also the infrastructure below that. So operating systems, runtime environments, servers, network infrastructure like routers, switches, all those kind of things. But we can adapt that a little bit to better fit Salesforce. So you can also consider C, so the information system architecture, to be sort of a functional solution architecture to Salesforce. So really from a UX CX perspective. So you only define the process as the user would experience in Salesforce without looking too much at how that will be implemented in the backend. So how you would actually define the code and look at limits and capabilities of, for instance, Lightning Web Components or of flows or of Apex. It's really from a functional perspective. And the business architecture is even more abstract. That looks fully system agnostic. So you're not even mentioning IT here. It's just the way the business works. So in phases B, C, and D, you come up with sort of the requirements architecture. So these are architectural building blocks that you define, which is the what. So the sort of architecture you're actually looking for to get. sort of solutions. And then E and F, you translate those into solution building blocks, which is the how. So the specific way how you're going to implement that requirement. So a little more on that. Architecture building blocks really define the what. So they are completely unaware, for instance, of vendor, of product, of service, of version. It's a sort of black box definition of what you expect that component or step or system to do. It's really a black box description on that layer of what you are expecting. So you define the functional specifications of the APIs, how it interacts with steps before or after it, or components before or after it in the whole end-to-end process. And you define in a requirements way what it should do. And then later you translate that into solution building blocks, which really is the how. So you fulfill the requirements that are defined in the architecture building blocks by defining the solution. And those are then aware of vendor, products, service, version, etc. So now the architectural domains. Architecture domains are really the different perspectives, different views you can take to a solution. And typically these domains have a substructure. For instance, one perspective, one view you can take to architecture is that of security, but security has various different aspects to it. Key ones are authentication and authorization, for instance, but below those are a whole subset of different capabilities, different features that have to do with security. So you can have single sign-on, you have the login and password policies, you have the two-factor, multi-factor authentication. For authorization, you can define permissions, so what you are allowed to do in general, but also the record access, so with which records you are allowed to do it, so the sharing model in Salesforce. You have certificate and key management, which to some extent is part of the single sign-on and login, but also is sort of an entity on its own. You have encryption, there's various privacy aspects, there's the governance aspects for logging and auditing, like the other parts of the Shield solution. So security is just one perspective that you can take, which has a whole subset of different elements that you need to consider just for that part of the architecture without even looking at other parts. So what can it look like if you compare it with completely different areas of architecture? So for a building, you can have the structural architecture. So basically the girders, the beams, the concrete, maybe to some extent the glass, like the windows that form the core structure of the building, like to make sure it keeps upright, stays upright. Then there's the cosmetic part. So you want the building to have a certain appearance, certain look, which are not structural, but they're still part of the construction as a whole. Then there's non-structural mechanical elements to it. For instance, elevators, which are a mechanical device, but they're not part of the structure to keep it upright. You have electrical systems, you have the pipes for the water, and maybe if it's a high building, you have pumps to make sure you have enough water pressure at the higher floors. There are sewage systems, there's gas systems with maybe valves, and also systems to maintain the pressure, communications, etc. And for vehicles or other machines, there are also various different areas, different aspects that you can look at when you consider the full design of a machine or a vehicle. You have the mechanical aspects. For combustion engines, there's thermodynamics. Especially for electrical vehicles, there's the electrical part, so the power electronics. There's electronics like the control electronics. There's pneumatics, hydraulics, for instance, the brake system, aerodynamics, which has to do with the mechanical part, but it's sort of a discipline on its own, the way it looks. And the same thing applies to IT systems. So you have UX and CX, so really the front end design, where you design what the user interface looks like, or any other parts where the user interacts with the system in some way. You have the data architecture, which of course includes the data model, with the different objects, the different fields, the relationships between the objects, but also, for instance, the backup and archival and recovery strategy, restoration strategy, master data management, well, security already covered. Automation can be flows, can be Apex, can be out-of-the-box functionality that has some automation aspect to it, like the lead conversion, for instance. Integration, there's a ton of areas that you can look at. Infrastructure, and if you don't have a cloud as a service platform, but really design your whole IT system from scratch, including all the infrastructure, you can also design the network infrastructure, you can design the server infrastructure, operating system, runtime environment, etc. And then there's the governance aspect, which is also a key aspect of the structure as a whole, and includes things like the DevOps process, CI/CD, testing. So there's various different parts, aspects, characteristics of a solution as a whole that you have to consider. And each of those apply to the different layers and the different methodology domains. So the business architecture, the solution architecture, and the technical architecture. Not all of them, but most of them are applicable in all of those areas. Then the third axis, architecture layers. So as we as discussed earlier, with the system of a system thinking, most systems are far too large, far too complex to really design in one layer, because it simply gets too big to cover all of it in one design. If you would draw an end-to-end process diagram, even for the sales process, with every tiny step involved, it could be hundreds, maybe even a couple thousand steps, which is way too much for a single artifact. It becomes unreadable, not incomprehensible even for architects or developers, but definitely for the business. So to make it more understandable, more comprehensible, you can split it up and say that each layer for each single artifact only defines 8, maybe 15 at most components. And then each component you can zoom in on, dive into basically, and that component becomes an artifact of its own on the layer below it. And then in that layer below it, you can have, again, 8, 10, 15 components just to define the sub-steps of the higher layer components that you're describing now. And most of those frameworks do that 4 or 5 layers deep. So a single building block in a higher artifact becomes in a higher layer, becomes an artifact of its own in the layer below it. And SAFe, as I mentioned earlier, has 4 layers. So you have the enterprise architecture, large-scale solution architecture. So these are really solutions that encompass multiple systems, which could still be in the Salesforce ecosystem. So you could, for instance, have a process that involves MuleSoft, core platform, maybe CRM analytics, maybe also marketing cloud. So you can have multiple different stacks, really different entities in the system landscape that support one end-to-end business process, one-to-end solution. And to really design that end-to-end, you have a separate layer in SAFe. Then the essential SAFe part is the system architecture. So it's basically the architecture of a single system, of a single stack. So it could be the architecture of the core platform, the architecture of MuleSoft, architecture of marketing cloud. And within that, you split it up into separate teams for certain capabilities. Like you could have one team for Service Cloud, or even smaller than that, one team for instance, omnichannel. Would be a bit excessive in this example, but some systems are so complex that even for a single capability, you can have one separate team. C4 model, very similar. So at the top, you have sort of the enterprise architecture, the context. Below that, containers, which are sort of key capabilities, like really, really large solutions. In that, you have the separate components to a solution. At the bottom layer, you have the code. And there's also the L0 to L4, or sometimes L1 to L5, or L1 to L4, various definitions of that. But basically comes down to the same thing. You have the enterprise architecture at the top, and all the way at the bottom, there's the steps, or really the smallest components to a feature. So what can that look like in Salesforce? Well, enterprise architecture would be the full scope of Salesforce, and even bigger. It's the full enterprise architecture, so it's actually all systems, all stacks, all business processes. So for instance, if you look at the core processes of business, that's typically the management process, like the C-level. You have marketing, you have sales, you have operations, you have finance, you have HR, and those are typically the core processes that the business has. And if you are looking only at the sales process, you already go one level lower. So here you can define the end-to-end process for sales. That doesn't necessarily mean that it also maps to a single system. So the business architecture, so to say, in TOGAF doesn't necessarily map to the same entities in the solution architecture, which will already look at Salesforce. But those are roughly the same order, the same size of component that you'll be looking at. In Salesforce, it will be a single stack for the system layer, so a core platform, marketing cloud, MuleSoft, CRM analytics. Below that, you start looking at the clouds on the platform. So for instance, on the core, it will be sales, service, experience, then the larger capabilities, and finally, the small features like lead conversion, but also custom automation, like a single flow or a single quick action or a single Lightning Web component that does one thing. So now we know which different axes there are to architecture, and take a bit of a look of the traditional approach. So the traditional approach is business to technology and top down. So you move from the top left corner to the bottom right corner, where the business architecture really drives the information system architecture. So in Salesforce, the functional architecture, from a user experience, customer experience perspective, and then in turn the technology architecture, which to Salesforce will be the technical architecture of how you're actually going to implement it. So will it be a flow, will it be Apex, Line Web components, really the technical detail, also looking at governor limits and those kind of aspects. And on the other axis, the top level architecture, so the enterprise architecture, pushes down on the lower layers. So top level is leading, and the more down you go, the less priority it has. Basically, it's all defined by the higher layers. So this is typically an approach you take when you have full freedom. So you're building a solution from scratch. Everything is custom. That's also from back in the day when TOGAF was originally created. But nowadays with Salesforce, of course, it doesn't really work that well, which we'll get into later. So what can that look like in practice? Well, to stay away from the abstract IT, I took a house as an example. So if you look at business architecture on the highest level, it's basically what you want to use the house for. So you can cook in it, you can relax, like you have a sitting area where you can watch TV, or you can game. You want to work there maybe, especially nowadays with working from home, study, sleep. It's basically all the things you can do in a house. Then the functional perspective, the CX UX perspective, which in TOGAF is information systems, would be what do you need to support those business processes, those things you want to do in the house or with the house. So it means you need furniture, you need lighting. For the kitchen, you need appliances. You need rooms, and then you get to the technology architecture. Rooms are actually part of the technology architecture. So once you know what you're going to do and what you need in order to do that, you also can start looking at what's the sort of infrastructure that I need to support that. So you're going to need certain rooms, like the attic probably isn't a good place to place your kitchen in most cases. Sometimes maybe it is, but in most cases it's probably not the best place. So you want to make sure that the rooms also support the appliances, furniture, lighting, etc., which in turn supports the business process. So you go from business to technology, and technology in this case also has multiple dimensions, multiple layers again. So first you look at the rooms, then you look at the outer structure. Okay, so if I need these kind of rooms, then that means the house is going to be this big. So the outer walls have to be roughly this far apart. We have this many floors. There's a roof on top. And of course, to build a house, if you don't want it to collapse, it needs a solid foundation that's able to support the whole thing. And the implementation of traditional approach architecture is pretty much exactly in the reverse order. So for a house, you would first make the foundation and the outer walls, load-bearing walls, floors. Then when you have all of those, you can put on the roof. Then you can make the other inner walls, like the not load-carrying walls. You can put in the furniture, you can install the kitchen and the bathroom, put the appliances in there, lighting, the decorative parts like the paint, floor, etc., heating. And that way you can get from the architecture to the solution in a reverse order. So what can this look like from an IT perspective? For the implementation phase, you would start with the infrastructure. So you need a data center, which has power supplies, there's cooling, there's network infrastructure with the outside world. Then inside you have servers, switches, routers, sort of the bare bone infrastructure to support your applications. Then the next layer would be operating systems, runtime environments, so where the application actually going to run in, and the database is going to be running. And on top of those, you have the applications, databases, and within the application, you finally have the capabilities with the features as a smaller step. So what's the problem with this, with Salesforce? I already covered a little bit of in the problem statement. It's that the SaaS and PaaS characteristics of the system will conflict with the influence. It's no longer solely left to right, so going from business to information system to technology and top down, but it's a mix of both directions. So what does that look like? If you look at the top layer, there's not a conflict yet, because in the top layer, you basically don't have Salesforce as something which you have to implement. It's just a single entity. So you have, for instance, one building block per stack. So you have one block for the core platform, one for MuleSoft, one for Marketing Cloud, etc. But there's no implementation level detail yet, so there's no problem yet there. But the issues then start in the lower layers, so C2 to C4, where you have to define how you're going to implement that for two reasons. From the SaaS aspect, there's functionality provided out of the box. For instance, you get standard objects, you get things like omnichannel, like lead conversion, territory management, forecasting, all kinds of out-of-the-box capabilities that have a certain way of working, and you can configure those to a certain extent, and you might be able to even extend them a little bit, but at the heart, they are fixed. They are integrated part of the platform. You're not able to see the source code. You're not able to change the source code. You're often not able to really extend their way of working, only in a very limited way, which means that you want to leverage how those components work and not build something next to it that's very similar. That might be 60, 70, 80% the same, but only 20% different, just because you don't like that 20% of the standard solution. And that can be said about out-of-the-box functionality of the clouds from Salesforce, but the same can be said for Salesforce industries, so from Velocity, from add-ons, from App Exchange apps that you can install, basically anything that you can buy or already get out of the box with the platform is a preferred solution to building the near identical thing custom, especially if there's no way around having the out-of-the-box functionality, because then there's two things that do the same thing next to each other that might conflict. Another good example would be that if you replace opportunity in your data model, you will get all kinds of issues with quotes, with order, and also with the line items for those, maybe with the price books and the products. So you want to leverage those parts. The same thing applies for the PaaS aspect. So the technology architecture is fully fixed in Salesforce. You get the platform out of the box. You cannot change the governor limits. You cannot change the performance. You just get that. So if there's any solution that would no longer be performant or no longer be secure, or would break because it would exceed governor limits, then that means you have to change the solution because you cannot change the technology architecture. So that's these arrows going in the opposite direction of the previous diagram I shown. So it's no longer that the information system architecture or the functional architecture drives the technical architecture, but it's the other way around. And that's driven not fully right to left anymore from the top layer, but sort of diagonally. Because if you, as a solution, pick Salesforce as your system, as your application that you want to configure your implementation in, that means that by making that decision, you get the SaaS aspect, which is over here. So it's the functionality you get out of the box, but also the PaaS aspect, because it's not a separate thing. You get the whole thing together. You cannot say, I want the SaaS functionality, but I'm going to run it on my own stack. It doesn't work like that in Salesforce. So basically, once you pick Salesforce over here, you get SaaS and you get PaaS, and the PaaS part is pushing back because there's zero flexibility. You just get it. So what happens if you still try to force the traditional approach of architecture? So the one we discussed, moving from business to functional to technical, and from the highest level layer to the lowest layer. If you try to enforce that on a Salesforce implementation project, what you see is that for every requirement that doesn't really fit, you cannot leverage what you get out of the box because you really want what is defined in the requirements, and we're not going to compromise. So that means that you have to customize pretty much the entire solution, which can to some extent be done with the point and click automation, which you probably already don't want. But even worse, you are most likely going to add a lot of code, a lot of LWCs, and a lot of Apex code in your solution to really have that full flexibility to build exactly how you want. The problem is that Salesforce was never meant to implement that way. There are better platforms for that. To some extent, you could use Heroku, but maybe if you want the full flexibility or almost full flexibility, you would maybe go even one layer deeper to IaaS, so infrastructure as a service like AWS, Azure Cloud, Google Cloud. So you have much more flexibility in how you implement it. With Salesforce, you don't have that. So you will have a lot of code to build almost all your solutions custom to really implement it the way the business wants it, which means that the implementation is very likely to struggle to stay within governor limits, will no longer be performance. It will probably be not very easy to understand the solution, to maintain it, to extend it. So you get all kinds of problems with the implementation. And these issues are typically created on the requirement side. So if you are really strict about what you want, allow no room for compromise, then you are always going to struggle with finding something standard that fits. There's always some part of it, even if it's only a couple percent, that's not aligned with the way you want it. If it's out-of-the-box functionality that you cannot configure well enough or extend well enough to align those last few percent, then that means that you might need to build almost the identical thing next to it to really provide it the way that you want it. Which means that you are not only pushing the platform from a limit perspective, it's also that you are replicating all functionality. So you get duplication of responsibilities, separation of concern can no longer be fully fulfilled because some concerns are not handled by one functionality, or one capability or one system, but by multiple, which is typically something you want to avoid in architecture, because really a bad practice to build the same thing in multiple places. Because if anything changes to your way of working, you also have to change it in multiple places. Then the other way around, so bottom-up architecture, which in my opinion isn't really architecture. This is what you typically see in much smaller implementations. There's little to no big architecture conducted at the start of a project. It's basically you get the backlog. The backlog mostly defines user stories on the C3, C4 layer. So capabilities at most likely single features, single functionalities. And the solutions are defined on a story by story basis. So each story gets its own solution direction, its own instruction for the developer, but there's very little holistic view on the end-to-end solution or the end-to-end architecture. You don't see a lot of design effort going into designing the stories together as a sort of package, like a larger solution. So you can have various problems there. One is that you start focusing too much on optimizing single steps instead of optimizing the end-to-end process. The same goes from like really on a business level. The same goes for the functional aspects like the customer experience and the user experience. And the very same thing again applies to the technical architecture, which means that your solution, your implementation won't effectively and efficiently consume resources because we'll focus too much on the wrong areas. Your end-to-end process won't be anything near the optimal solution in most cases. And you can run also into all kinds of conflicts. And what you typically see is that those conflicts are also not resolved holistically, but are encountered during implementation and also resolved on a case-by-case basis. So if two stories conflict with each other, then we first fix that conflict, and then we later find out that, let's say those were story A and story B with their own solutions. Let's say B also turns out to conflict with C, then we have to again do the same thing. We solve the conflict between B and C. So it's a very, yeah, sorry.
We do have a question on chat. So do you would like to hear the question right now or maybe at the end?
Yeah, I can do it now.
You'd like to check it from the chat or you want me to tell you the question?
Can you read it out?
Yeah, so it's from Olga. She said, how do you approach when the client is not ready to compromise for that 20% of missing functionality in out of the box?
That's the key part of the presentation. That's what I get into later. That's a change management. So I'll get to that.
Okay. And the second part of the question is, or their processes are so unique, complex, specific that out of the box does not work for them?
Also covered later in the presentation. So I'll get to those.
All right.
So maybe if they are not fully answered at the end, I'll get back to on those then.
Okay.
Right, so we get into the more interesting part. So the title of the presentation had to do with change management. So the question we're trying to answer here is, why is change management a key aspect to a better approach to Salesforce architecture? It has everything to do with finding the right balance between functional and non-functional. So it means that if the program management office, sort of the bigger version of a product owner, so usually for a very large program, it cannot be a single person anymore. So if a program management office, they define the what, so the functionality that they want to do the business in the way they want it. Their mandates should be balanced out by the architecture capability. So the PMO defines the what they want and what they want to get. The architecture capability defines how they will get it. And those two need to be in balance. What you typically see though, is they're not in balance. So the business is pushing much harder than the architecture capability, which results into implementations that are not scoring very good on their non-functional requirements, compliance, and performance. So how can we ensure that mandates? That has everything to do with KPIs. So typically the business has KPIs for all kinds of aspects. For instance, the revenue, profitability, margins, all kinds of aspects that measure the performance of the business side of things. The same weighting, same level of scoring in the end-to-end picture should be considered for the architecture capability. So the architecture capability is the department, the practice that defines the architecture for the solution. They should also have KPIs, and those KPIs are typically defined around two things. One are the architecture principles, and the other are NFRs. And for both of those, you have binary versions, meaning that you can either be compliant with a principle or non-functional requirements, or you're not. And there are also analog principles and NFRs, where you can be less performant or more performant or compliant, but it's not a yes or no thing. It's a sliding scale. For the binary principles and NFRs, risk management is really your friend. So in many cases, you will say that these simply have to be compliant if it's either yes or no. If it's not, they're not going to build it like that. We have to change the process. We have to change the functionality, the requirements, because this way will never work in Salesforce. And why is risk management your friend? Because risk prevention and risk mitigation aren't things that can be postponed. If you underestimate risks or neglect or ignore risks, that can seriously impact your business continuity. And people also tend to really underestimate risks in IT because it's so abstract. Earlier on, I mentioned the metaphors around buildings or vehicles or machines, more tangible things that can really help explain the risk of something. And because IT is very abstract, very intangible to customers, and they simply don't understand our language. So one metaphor that I came up with a while back that I kind of like for this is, let's say you have a house and you could spend maybe 2,000-3,000 euros for fire extinguishers and smoke detectors and carbon monoxide detectors to some extent prevent a fire, or at least prevent a fire from escalating further. And if a fire happens, you can use the extinguishers to extinguish the fire before it causes any real damage. If you don't do that, and your house does catch on fire and completely burns down, then it's no longer an option to still spend the 2 or 3K for the fire extinguishers and the smoke detectors, etc., because your house is already burned down. It's no longer applicable. You might have to tear down the whole house. You have to sanitize the grounds. You have to, maybe the building code has changed in the meantime, so you have to come up with new designs. You have to get permits. You have to build a new house. Well, in between you have no house, so you have to bridge the gap maybe with a hotel. And that's one very tangible example where it makes sense that once the house already burned down, it doesn't make sense anymore to invest in a preventive measure. You're no longer talking about 2 or 3K. You might be talking about 1.5 times the value of the house, because you have the cost of tear down, new designs, bridging the gap, building a new house. Maybe labor cost has gone up, maybe material cost has gone up. So it's a completely different situation after it has burned down than you were in before. The same thing also happens in IT. If you don't have backups, or you might have backups, but you have no proper method to restore them, once accidentally the whole database somehow crashes, like maybe someone accidentally triggered a batch process that start deleting thousands or even millions of records. If you don't have any way to restore them, your business continuity is seriously affected. You can no longer fulfill the process that relies on that data until you've restored that. And it doesn't help you very much, especially if you didn't have backups, to then implement a backup solution. It won't work retroactively because the data is already gone. Another example with a vehicle could be that, well, we can make a race car and we can make it 15% faster. But if we do that, there's an 8% chance the brakes might fail. If we don't make it faster, it's maybe only 1 in 1,000. So those kind of metaphors can make it much more understandable to see why it could be a very bad idea to neglect an architecture principle or neglect a non-functional requirement. Let's see. And that, and that also comes back in the way you prioritize work in implementation projects. I particularly like the way short job first methodology in that area from SAFe, because it doesn't just look at story points, but looks at cost of delay divided by job size, where cost of delay is the combination of business value, time criticality, so how important is it to get this thing fast, but also risk reduction and opportunity enablement. Well, business value we almost always see, time criticality as well, opportunity enablement to some extent. Usually we want direct business value, not something that can help deliver value later. But the thing that's neglected most is the risk reduction component. So if something can reduce the risk by a lot, that might weigh a lot stronger if you use that way of prioritizing work than something that provides direct business value. If the business value is really low compared to the other story, having a really high risk reduction. So how do you enforce this balance? Let's see. Yeah, so what I mentioned earlier, many of the binary NFRs and architecture principles must be non-negotiable. So you have to be compliant. You must be compliant on that side. I think that's there's an error. It should be binary, not the non-binary. Meaning that if they aren't compliant, if you cannot come up with a solution to a certain business requirement that fits the non-functional requirements, that fits the architecture principles, it means the functional side must change. And this is where change management comes into the picture. You really have to change the organization, the way of working, and you have to coach them in that. So you have to train the users, you have to take them through the process, help with transitional steps. So also change the organization, change the way of working. It doesn't happen overnight. So you really have to come up with intermediate steps to facilitate that process. And to get back to the earlier question of Olga, you really have to convince the business with those KPIs that it's about the end-to-end core. So you cannot only look at the functional side, you must also look at the non-functional side. So you cannot just focus on what you get, you must also focus on how you will get it. Will it still be a qualitative solution? Will it work over time? Will we be able to extend it, to modify it? Will it be able to evolve with our business? Maybe our competitor will come up with a new solution that will seriously impact the market, and we have to come up with new ways of working anyway. Or something else changed in the world. That means we have to evolve. If your solution cannot be modified or is really hard to extend, that means that over time, the business value will also be a lot lower. Let's see. Yeah, another thing to add here is that this change management is not a kind of change management where you redesign the whole business anyway. So there's the change management. If that's the case, you do it upfront even before you start architecting Salesforce. Otherwise, you will have way too much redesign anyway of your solution. But if you have a really large change management trajectory anyway, then as part of your sales architecture process afterwards, you can make small changes to that. Because if the process is going to change anyway, then it's less impact on top, relatively speaking, to change it a bit further to properly fit the sales way of working. But this change management for the architecture process is really about making small changes. So if something is for 80% or 90% a good fit, it's about changing that last 10% in the way of working to properly fit the standard solution. And one thing that can really help the business is emphasizing that it doesn't mean they get less. It means they get something slightly different. So it's still a mature solution. It's still a fully functional solution. It still provides the same level of end-to-end capabilities, but not less, just in a different way. So what can this look like in the architecture approach itself? The starting point is still the same. So it's still business to technology and still top-down as starting point, but you combine that with the reverse order. So you will combine top-down architecture with bottom-up architecture, where you leverage out-of-the-box functionality, but also app exchange solutions, other add-ons, like for instance, Shield. And you respect the platform characteristics, especially the multi-tenant parts, the cloud parts, which are some of the key drivers behind most of the governor limits. And for the areas where this means you have to change the functional side or the business side, you leverage change management as a tool to facilitate that process. So what does the first step then look like? You create a C1 architecture, so the highest level enterprise architecture, and you also start with creating the full depth of business architecture. So your core processes like sales, HR, operations, marketing at the top, and then the different modules or in the process as a whole. Then the capabilities within that process, so the sort of most important large blocks of a process, of a functionality, and then finally the steps. And this is all system agnostic. It doesn't look at IT. It's really on the way of working sides, but you already decide what the real steps on a most detailed level will look like. So maybe you already know that at some point some form needs to be signed. You don't know at all what the form's going to look like. Just looking at business architecture, it could even be paper, or it could be by phone. Maybe you have nothing to do with Salesforce or any IT system, but you already know that at some point there has to be a form and it has to be signed, or it has to be approved in some way. Then once you've come up with the high-level end-to-end architecture and the business architecture, then the next step is that we assume that there is one requirement for a system. So for the functional side of things, the application side of things, and that requirement, so the architecture building block, translates into a solution building block that leverages Salesforce. And at this point, we already know that the business architecture that we defined in the previous step will start driving the functional solution architecture of everything below the building block that converted into Salesforce. And from a solution perspective, Salesforce will automatically also drive a lot of the solution architecture of that solution. So
another question from Olga. So
yeah.
what is your go-to argument to get buy-in from the business to change their business processes when needed?
And that's part of the last couple of slides.
Okay. Okay. So wait.
I'll get to that.
All right. Sorry, I think I accidentally mute you. Can you please unmute yourself?
Can you hear me again?
Yes.
Yeah, great. So the first part is still the same. It's still the top layer and still a business, which in turn will drive the lower layers and business driving the functional solution. This part remains the same. Then the fun starts when you start looking at the solution architecture, the functional part of things, and there find out that it doesn't really fit with the out-of-box capabilities of Salesforce. So maybe you find something that is no longer compliant, no longer in line with, for instance, the lead opportunity quote order way of working in Salesforce, or it doesn't fit with lead conversion, or maybe it's with any large functionality block, maybe the planning and field service, or with territory management. There's one capability that could to some extent be a good fit, but then there's a significant percentage that's not aligned, so you have to come up with something that's mostly in line with the out-of-box functionality, but different enough that you have to build something custom next to it to replace it, basically. That's one option. The other one is that if you do that, the technology architecture starts pushing back. So you have to customize so much that you're going to hit governor limits, or your solution might still stay within the limits, but it's no longer performance. It might take 5 seconds to open the page layouts, or when you edit the record and you save it, it takes 20 seconds before the save is fully processed, which will be unacceptable. So that's a point where you say, well, it's no longer in line with our NFRs. Maybe it's non-compliant with the yes/no NFRs, or you say that the analog scale, like the sliding scale NFRs, it gets below a certain threshold. That's no longer acceptable. That's the point where you say, well, looking at all those NFRs that have KPIs on them that should be considered just as much as the functional KPIs for the business, there's the point where NFRs start weighing stronger and we have to push back. So we need to change the implementation, the functional solution. When that happens, that means we will also need to start changing the business process, because if the functional solution changes, then it will no longer be a solution to the business side of things. It will no longer fully solve for the requirements that were set on the business part, meaning that you have to leverage change management to come up with a slightly different way of working that's in line again with the out-of-the-box way of working of Salesforce, or with an App Exchange solution way of working that will be a good fit to most extent, but not in full. So that's where you start seeing the reverse order horizontally. So from the technical side of things to the business side of things. And then finally, you repeat that process, because once you've gone through that, you will find that it happens again and again to a lesser extent, but still in a very similar way. So instead of going just top down and just left to right, it'll become a process where you start top down, left to right, and then you move right to left and bottom up, and then down again. And it will move in sort of a saw pattern that sort of converges to the middle. So looking at my mouse, basically go top down, bottom up, top down, bottom up, and you'll see that the sort of amplitude will get smaller and smaller until you get to a sort of optimal state where you've fully weight the high-level architecture with the low-level architecture, and the business side of things with the technical side of things. So it converges to the optimal point by using this iterative approach that looks from business to technical and reverse, and it looks from enterprise architecture to the definition of really the smallest features and back up to enterprise architecture. And in some cases, you'll find that there simply isn't an acceptable compromise. Maybe it simply doesn't fit. And in those cases, you might even look back to the first step and say that, well, Salesforce might not be a good fit for this, which will suck because you might have already signed a contract for a couple of years for licenses. So you probably don't want to stop with Salesforce right away, but could be a step like you come up with a new end state architecture and new transition architectures to bridge that gap. But at some point you will phase out Salesforce and come up with a different solution, with a different system. So maybe you say, well, we don't want to use Salesforce because it doesn't provide the level of flexibility we need. So we're going to build something custom on Heroku, or maybe go even one layer deeper and build something on AWS or Azure Cloud or Google Cloud. That's sort of most extreme case. In most cases, there is some way to compromise. You just have to convince the business that what you get is just as important as how you get it. So potential challenges, and Olga already named a few, is that it's quite uncommon in terms of maturity that businesses have these balanced KPIs looking both at the functional side and the non-functional side. Quite a high degree of organizational maturity, of IT maturity, of risk management, which in many organizations, in my experience, is not in place. You will get all kinds of arguments saying like, this is not how we do it. It's we've always done it like this. It won't work for us. It's not aligned with the way we work. Well, the first one, if it's the way you've always done it, then I'm already questioning, okay, how up to date is your business process in the first place? Is it still aligned to what your customers are looking for? Is it still aligned to the current market circumstances? Because if you always done it like this, it means you haven't evolved at all. So that's probably already a good reason to start looking at the process in the first place. And this won't work for us. It's not aligned with the way we work. That might very well be so, but that's when you get into the risk management part of things, that if you don't look at how you get it, only at what you get, then there's a high chance that at some point it will go wrong. Your implementation project might fail, like you get serious overrun on timeline, serious overrun on budget. It might take 2-3 times longer. It might be 8 times, 10 times more expensive. And in the end, it will be a solution that's also not what you want. And it's not aligned with the way you work either, just in a different way. Maybe it's functionally looking just at the bare requirements, satisfies the functional acceptance criteria, but if no non-functional acceptance criteria were defined, or you simply ignored them or didn't comply with them, then your solution might be so unperformant or so insecure that you get hacked or your data get leaks, and you still have a huge risk. You still don't get the business value or the return on investment that you are looking for, that you are expecting, might even be negative. Slightly better argument that you can expect from a business is that if we adopt a standard way of working, we lose our unique selling point. So there's a reason why we're different, is because we want to separate ourselves from the competition. Everybody else already does it in this standard way. We want to do it differently because that's how we are more competitive than the others. That might very well be so. But then the very important part is to really understand what drives your competitiveness. What is your unique selling point? So what generates business value for you? What generates revenue for you? What generates profitability and margins for you? It's about measuring your business and really analyzing the outcomes of that to understand which things have effects and which things don't. And if there is a conflict, if there is a solution in Salesforce that's not aligned with the way you work, that you take the pain where it has the least impact. So if you need to change your way of working, or maybe the other way around, you don't want to change it, but you accept lower NFR compliance or lower architecture principle compliance, that you do that by prioritizing and optimizing the things that have the most impact on your revenue, and that you make the changes to your business to better fit with Salesforce or standard solutions, where there's the least impact. So you stay as close as possible to your optimal way of working in terms of the aspects that really drive your competitiveness, that drive your profitability, your margins, and you change the parts that don't really drive your competitiveness and profitability. So, for instance, HR it's quite an internal process. Often doesn't have much to do with your customer interaction and with your partner interaction. So it doesn't have much impact on the buying side of things or the selling side of things or the fulfillment side of things. I mean, that's probably an area where you can compromise a bit more, stay closer to a standard way of working, instead of going all out on getting it exactly how you want it from a functional perspective at the expense of technical compliance. Another very strong business case is that if you leverage out-of-the-box functionality, like the out-of-the-box functionality from Sales Cloud, Service Cloud, App Exchange solutions, add-on solutions, is that you can get a much faster time to market. And the strong argument here is that it's not just about a delay. If you can really be first with something, like you know that you are working on something, maybe a new offering, but you also know your competitors also working on that. If you can beat them by 3 months, 6 months, maybe even more, by using standard functionality, then the value you're going to realize will be close to the full potential, but their value is much lower because you already took this market share. If you don't do it like this, what your competitor does, then it's the other way around. So this is the potential you could have realized. This is what you expected would be if you are delayed because you built a custom solution. But by then, because your competitor was ahead of you, you can no longer get to the full potential because they have already taken that market share. They were ahead of you and they're now the leading provider of that new service or new solution or new product. And your potential is no longer the full 100% of what it was before. It's only the part where you are unique enough to compete with what they have. So time to markets and the impact of that on potential value that you can realize is a very strong argument to stay closer to a standard way of working. Another ones are finding the right balance. So I mentioned earlier that if you see operations as the business, so they define what they want. They want any functionality, anything that can provide new services, new products, new solutions to customer, can deliver them faster, can deliver them with higher margins, higher profitability, can ramp up the volume. Anything that will push the revenue side of things and the profit side of things. But if you only look at what you get, but completely neglect of how you get it, with what quality you get, there's a serious risk of business continuity being impacted. At the same time, there's the finance aspect. So what you want as a certain cost to it, you have the implementation cost. So the business value provided by the new features that you want has to outweigh the cost you have to make to implement it. But in that is also the cost of implementing it in the right way. If you don't do it and you have a risk, then, for instance, because you have a business continuity risk, that drives back into the finance part. If you cannot do business because your system is down or because your data is gone, or you were, I know you had the thing a couple of years back in the Rotterdam harbor where there were, what do you call it, like the ransomware. If you cannot operate any of your systems, that also has a huge financial impact. And that's not on the business value side of things, it's on the opposite side of things, it's on the risk management side of things. And that's about find the right balance. You can not only look at what you get in terms of direct business value or in opportunity enablement, opportunity enablement, you also have to look at the quality and the risk it poses of not having quality. And that was it. So thank you for your time. And now I would like to open the floor for questions and thoughts and feedback and discussion. Abdel, can you enable the speaker option?
Yeah, I did. So so you can unmute yourself, guys. So if you have any question or anything, so you can just share your thoughts.
Hey, Kid. All good here. I just want to thank you for the presentation. It was very informative. So I definitely picked up a few tips here and there. I personally find it difficult to do this change management when it comes to big enterprises, especially global, because they do have their processes there for a reason and for some time, most likely already. So do you have experience from your professional experience when it comes to huge enterprises where you did manage to sway them towards out-of-the-box functionality instead of them pushing towards like, hey, sorry, no, that's not going to work because we did it XYZ for so many years already?
Limited, but the thing is that we must accept that we are not good at everything. There are other people that might be better at this. So I know that at Capgemini, for instance, there's a whole department for this within Capgemini that does this. Same thing in the industry as a whole. Change management is typically the domain of the big three. So you have Bain & Company, McKinsey, and Boston Consultancy. And those are the kind of consulting partners that specialize in business consultancy and strategy consultancy and change management. But many of the large IT partners also have departments for that. So I don't mean to say that the change management aspect to architecture is something that you can do yourself as an architect. It's something you probably need other people for, really have a skill set for that. It's just that you have to leverage that. So you cannot properly, in my opinion, do sales architecture without change management, because the system is just not flexible enough to implement exactly how you want it without any compromise on what you get.
Okay,
so
thanks.
that's my answer in short. So it's probably that you need to leverage the skills of other people.
Okay, and find as many executive sponsors as you can.
Sorry?
And find as many executive sponsors as you can.
Yeah, definitely. So it's the metaphor about the burning house, for instance, is something that might resonate well with upper management, because it's very easy to understand that if you don't look at the quality side of things or the risk management side of things, that the impact of a risk actually manifesting itself, actually happening, is much higher than the potential benefits that you get from having that feature exactly how you want it. So the risk management is the same as opportunity scoring. Opportunity, you also have a pipeline where each phase has a certain standard conversion rate. So in the first phase, it's usually it's a 10% chance it will convert to a win. In the last stage, it might be 95% that converts to a win. And there's a certain opportunity value. So you know in every phase what the value is to your pipeline by simply multiplying the business value with the chance it will convert into a win. The very same thing applies to risk management, but just in the opposite direction. It's a negative value. So if you already know what a rough chance of a risk manifesting itself would be, and what the impact would be for the business, because you won't be able to conduct your business, or you won't be able to conduct it on full performance. Maybe you have to scale back, like you're a manufacturer, and you have to shut down 2 production lines out of 7. Then you can already make an estimation of what the direct impact of that will be, but also the indirect impact. So sometimes direct impact is not even that high, but the impact on reputation might also have a huge impact on your way to sell new contracts or sell new services or products. So you have to convince them that that opportunity enablement side, and the business value side should weigh just as strong as the risk management side, and that's why you want to take a hard look, a strong look at quality of how you deliver things, not just on what you deliver functionally.
Okay, thanks.
I've got a question as well. It's Guy here. Hi, Kid.
Hi.
Thanks for the presentation. That was really nice. I was wondering, what is a good way to come up with a good set of KPIs to use in this process? Is there like a library, or do we need some skills from somebody particular?
Well, the KPIs on the business side are typically already in place.
No, I mean
So
the other ones.
So for the business, they already have them. The other side of things, on the technical side, is driven by NFRs, so non-functional requirements. And a good start with that is just Googling the term, and you get to the Wikipedia page. And NFRs are already also known sometimes as the ilities, because it's things like extensibility, maintainability, performance and security. Don't have something with ility, but a lot of them end with ility. And they're sort of perspectives to how secure something is, how performant something is, how easy to read, maintain, extend, integrate, all those kind of aspects. And those are also requirements. So you have to discuss with the business what is acceptable to you in terms of security, what is acceptable to you in terms of performance. So a non-functional requirements for a user interface element could be the loading time. So how many milliseconds can it take to load this screen? How many clicks can it take for a more UX, CX perspective? How many clicks can it take to walk through this process? How many screens, how many tabs in Salesforce do users have to go through for this end-to-end process? So NFRs are just requirements that you have to define, and the KPIs are then around the compliance if it's a binary requirement, so it either complies in full or not at all, or sort of performance rating that you say, well, it can be fully compliant, can be not compliant at all, but can also be somewhere in the middle. And if you say, well, anything below this threshold is simply unacceptable, and that you have a sort of scoring model for that below a certain threshold, it means they always have to change at least a little bit on the functional side. If it's above the threshold, then it still has a strong negative impact. And then it's about coming up with a formula that weighs the functional, the business side of the KPIs just as strongly as the non-functional, the technical KPIs, so the quality KPIs.
Yeah, that is definitely a good way of looking at it.
Yeah, and the principle side of things, architecture principles are, for instance, things like prioritizing out of the box versus custom, or that you prioritize buy versus build, or that you prioritize point and click over code. Doesn't mean that you always have to go that way. There can be very good reasons to not buy something but build it, or to not use point and click automation but to use code automation or customization. But also with that, you have to weigh the benefits with the downsides, the pros and cons. But the key element is that they have to weigh equally, and with the weighing equally, you need people on the technical side, so the architects. You need people on the business side, so the financial people. You need the top management to sort of enforce that balance, to say, well, we respect the functional KPIs just as much as the non-functional KPIs. And you need the risk management people to really help you out with calculating the risk value, the weighted risk value of not complying with something compared to the opportunity enablement side of having something exactly the way you want it from a functional perspective.
Thanks.